Okay. Question number 9. Choose the molecule that does not have a dipole moment. So the easiest way to identify dipole moment is you just draw the structures of these compounds. That is the easiest way. Okay. So if I again use the board for this, the okay, so the first one is SF2. So sulfur, there are 6 electrons. So 2 of them will be participating in this. So remaining 4 electrons. So in principle, it will be like this as lone pairs. So what is the shape? It is bent. Or we can say angular. 2 bonds, 2 lone electrons, bend or angular. This is the shape according to VSEPR theory. Okay. And there is another one called electron pair geometry. Okay. When you have electron pair geometry, you have to count the sigma bonds as well as the lone pairs as repulsion unit, total repulsion unit. So if you want to get the electron pair geometry, you have to count all 1, 2, 3, 4. So there are 4 bonds now for electron pair geometry. So it will be tetrahedral. Okay. Then the second one is PCl4F. So phosphorus, there are 5 electrons, and you have already 5 atoms participating in bonding. Okay. So this will be like this, mostly like this. Like this. You can draw like this. For an example, I will put like the chlorines like this, fluorine like this. So there is a electron pulling, right? There is a electron pulling. Okay, so in fact, this will be like this. This will be like this. There is a dipole moment towards certain direction. Okay. This will have dipole. In the similar way, you can draw SF4 and PCl3. But when you go for SF6, remember, so this is what we called a octahedral geometry. Okay, which is if you get this plane will be this. Okay, and there is a bond on top and bond on bottom. So 4 atoms are in the plane like this, and there will be one bond on top, one bond on bottom. So if you check the forces based on the electronegativity difference, this will pull like this, but in the opposite there is another same electron. This will pull like this. This will this. So at the end, you can see all these pulling forces are opposite to each other in the same line of action, equilibrium of forces, you remember in physics. So at the end, the resultant force is 0 to a certain direction. So if this is 0, there is no dipole moment, which means there is no clear charge separation, delta plus and delta minus. But here when you see there is a clear charge separation, fluorine is pulling electrons, so there will be delta minus, delta minus, delta plus, clear charge separation, positive side, negative side. So as this, negative side, positive side. The others as well, SF4 and PCl3. So remember, dipole moment means clearly there is a charge separation within the molecule. For an example, another example like this is water. So water clearly has a dipole moment. Why? Delta negative, delta negative, delta positive, delta positive. Divide it like this. Negative charge, positive charge. Okay. So this has the dipole moment. Then we come to another important molecule. So these are additional notes, right? Remember. For an example, I2. So I2, you can see there is no dipole moment. There cannot be dipole moment. But remember, if you have another I2 molecule like this, when it comes closer, this electron cloud will have a more or less a repulsion. So this electron cloud will repulse this, and at the end, it will be like this. Where here there will be a slightly positive charge, here there will be a slightly negative charge. And now this is a dipole. Okay? But in this case, this is not a permanent situation. Therefore, that is why we call this as induced dipole. So I2 has no permanent dipole. Its permanent dipole is 0. Like SF6 in this question, its permanent dipole is 0. But I2 can be induced a dipole like this. Therefore, I2 will have an induced dipole. Okay. There are some molecules like this. They don't have dipole moment which are permanent, but they will have an induced dipole moment. But for a molecule in general, to check the dipole moment, we get permanent dipole moment plus the induced dipole moment. Okay, up to that, that is fine. No need to know more than that. Okay, so the easiest way to get the answer for this is just try to get the structure and decide the shape, and you can get the pulling of electron based on the electronegativity, and you can just see the symmetry. That is the only point. You just see whether the molecule is symmetrical and the pulling electrons, the dipole moments are cancelling out or not. That's all.